Good evening. Thank you for joining us this evening. We're live here at the Mile High Astronomy Store in Denver, Colorado, to introduce the new Vespera Smart Telescope from Vaonis. So these are awesome little instruments. We're going to start off tonight showing a little demo video from Vaonis on these. And then we'll get into some of the sample images and a walkthrough of how to actually use it. And if the weather gods allow, we'll do a live demo at the end of all of that. So with that, let's get started with the video.
At Vaonis, we want to give everyone the opportunity to explore the universe that surrounds us. In 2018, we changed the game of astronomy by creating the first smart exploration station, Stellina. Thousands of astronomy enthusiasts have shared their excitement and their own pictures of the universe.
And here it is.
C'est pour vous présenter une technologie folle.
They have a very cool product that they're just releasing here at CES. We go
Today, we're going a step further to make astronomy even more accessible. Today, we introduce Vespera. We conceived Vespera to be the perfect combination of a telescope and a camera that will help you reconnect with the stars. Observing and capturing the wonders of the cosmos can be difficult. People often say telescopes are challenging to use, heavy and cumbersome. With Vespera, that's no longer the case. Designed for you to share space observations with your loved ones in real time, we opted for the most comfortable eyepiece, your mobile device, combined with our app. You can now take your own photos of the moon, galaxies, nebulae, and so much more. Vespera only weighs 10 pounds, is 15 inches tall, and can fit in your backpack. It is time for you to go explore the world and experience breathtaking outdoor adventures. Super easy to use. Just set up the tripod using the adjustable legs and press the button. Let Vespera come to life and calibrate itself through your GPS device and starfield recognition. Using our app, simply select the object you want to observe, and Vespera will point and track it, compensating the Earth's rotation. Vespera is also the perfect hybrid of compactness and power. It is equipped with a state-of-the-art quadruplet apochromatic refractor, one of the most accurate and powerful optical designs on the market, with zero distortion. Using the latest Sony sensor, developed for extreme low light, Vespera creates astonishing results. But the real magic behind Vespera relies on its intelligence, made possible by our team of engineers and software experts. We designed the most advanced, autonomous, patented image processing algorithm, allowing you to get mind-blowing pictures. While photographing, Vespera only keeps the best shots and stacks them on top of each other, revealing the brightest and sharpest images possible. To guide you, we designed a super user-friendly app. You'll get personalized recommendations on what to explore according to your geolocation and the astronomical calendar. Choose your destination among our catalog of celestial objects and learn along the way with our educational content. Capture your discoveries and share them with the world.
Hi, I'm Terry Virts, former NASA astronaut and commander of the International Space Station. When my kids were growing up, I really wanted to share with them my love of astrophotography and of the sky. So we would go out and look at the sky, see the constellations, see the moon. Honestly, it was easier to bring out a pair of binoculars than it was to drag that 75-pound, or 35-kilo telescope outside. And that's really the genius of Vespera. It's very easy to move in and out. It's much lighter than a real, big telescope. And it gives you an endless limit of things to look at in the sky, whereas a normal telescope, it's kind of like you got the moon, you got a couple planets, and then you're out of things to watch. So I think it's really something that's going to revolutionize the way you see the night sky.
Hi, I'm Scott Kelly, former NASA astronaut. I will never forget the first time I flew in space. It was a mission to repair the Hubble Space Telescope. And ever since that flight, I've just been fascinated with what Hubble has shown us about our place in the universe. My hope is that Vespera, having this own exploration station that you can take with you wherever you go, can maybe inspire your children to go further, to challenge themselves, to reach their dreams.
Standing on the shoulders of giants who came before us, we invite you to be part of space exploration history and to write the next chapters together. Somewhere in the vastness of space, a new journey awaits.
All right, so that is the Vespera, or Vespera, depending on how you want to pronounce it. We've heard it both ways. There apparently is no definitive answer there. We've had the chance to actually use this thing ourselves for the last couple of months, and we really have been very impressed with what it's given us in terms of images, in terms of ease of use, and how well the whole thing is put together as a package. So Vaonis really took a big step with the Stellina, the original smart telescope, and shrunk it down to less than half the size with the Vespera. Even the 50mm objective in this instrument is a heck of a nice optic. And while, me as an astrophotographer, I always want bigger and more and higher resolution and all of that. After using it for a while, that 2-megapixel sensor still produces some pretty darn impressive results. More than good enough for the vast majority of folks. The battery life, in my own experience, has actually gone more than 4 hours. I've actually had it out all night camping and still had about 20% battery left in the dawn hours. So that's pretty impressive. You can always plug in an external power bank to keep it going for even longer. The weight of it is only 11 pounds. These things are incredibly lightweight for as much power as they pack. And with their little backpack, it makes a really great little package. So I thought what we'd do next is actually do a little pre-recorded demo with the Vespera app, Singularity. And this is one that I recorded from my house just a week ago. And we'll give you a sense of the general setup process and initialization process. If you've ever used a smart telescope before, go-to telescope, you'll know there's a little initialization process that takes a few minutes, maybe a little longer. So we'll walk through this right now. Basically, with the Vespera, the first thing to do is connect to its Wi-Fi network. It creates its own Wi-Fi network. Just connect your device to that guy. Then you'll launch the Singularity app, and you'll see it'll recognize the telescope at that point. I've hit initialize. And this is going to tell the telescope now to open up, turn its optics up to the sky, and start its initialization process. While it's doing that, we can explore through the app a little bit. You can see all the different devices that are connected to the telescope, just me in this case, but the Vespera will accept up to 5 devices connected. You'll also see the telescope has its own internal storage, 10 gigabytes of storage. So you can store your images for later download. And we'll talk in just a second about what those images are. That last tab there, image formats, gets into the choice for what you're storing. So if you want, you can store at the very top those raw images, those FITS files, to do all of your own image stacking and processing, just like you would with any other astrophotography setup. The next option there is the stacked images, the JPEGs. So if you want to see the progression of the image from one step to the next, you can save every one of those steps. That next option, those TIFF images, that's going to be your final stacked image. So still a raw image, unprocessed, for you to do your own processing on, but all the stacking's been done for you by the Vespera. And then live images, that's going to be for the moon and the planets, where it's not actually doing stacking, but will let you save all of those individual images it captures every few seconds. You can see it's now in the autofocus part of its setup routine. We can take a look at that here. It actually goes pretty darn quick, since this is all happening just autonomously here. You can see as you scroll through the app, there's different news items and stuff that get updated when you're connected to standard Wi-Fi, weather information for your observing locations as well. And then the second tab at the bottom here is the object catalog. So the Singularity app will recommend different objects to image on any given night. And it has a large catalog of different nebulas, galaxies, clusters, all kinds of stuff. You can favorite items, that little blue bookmark there, and those items will show up under the Favorites tab. Makes them nice, easy access for later. And then manual, so you can manually define targets, things that aren't in the catalog, such as a comet, for example. You can enter right ascension declination, just like you would on any other telescope, computerized telescope. And hey, we're ready to go. So that was about 3.5 minutes to initialize. So we can now select our target, the Dumbbell Nebula in this case. And you'll see it's moving over to the target. It'll tell you how far away it thinks it is as it's approaching it. Gives you a few little fun facts along the way too. It'll take a test exposure to do a plate solve, check its position, and adjust as it needs to. And then it's activating the tracking. So basically right now, it's getting the telescope ready to acquire that first image. And in just a moment here, you'll see this fun little animation showing the photons coming into the telescope while it's acquiring those images. And you'll probably see this for just a few seconds before you get that nice blue ring. And there's our first image. That's a 10-second exposure of the dumbbell. Now it's 20 seconds. So we got a second image in there already. And you'll see every 10 seconds or so, another image gets stacked in here. You'll see at the top it says 30 seconds now. Bottom right corner, you'll see it says, has a little scale that's going to continue growing as we get more and more images in there. And this is not sped up or anything. This is what it's going on real time. This is a real-time recording. And you can see with just about a minute of data now, we've already got a pretty good image forming from what we started with just a faint fuzzy in that first 10-second image. We're going to let this go for just another minute or two. We'll get to that in just a minute. Hold your questions for now. That applies to the live stream too. If you have questions, we will get to them as part of the broadcast. Go ahead and type your question in, and we'll get to those shortly. The fun thing, one of the fun things about watching this is just seeing the image develop over time. And you can actually, if you want to, even just shut the app down, go get a bite to eat, cup of coffee, whatever, and come right back, connect your device again, and it's continuing to acquire data because it's all actually built into the unit. So you can see here we can actually scroll through that stack of images and see how it's built up over time. Go all the way back to the beginning and see how it's developed. And the app itself, we breeze through it pretty quickly, but for each object it'll actually suggest a recommended exposure time, how long to image it for to get the best result. In this case, for the dumbbell, I think that was about 30 minutes. So we will pop out of this demo now and look at that final image, about 36 minutes of data. So that's a pretty impressive result for an image taken from the Denver suburbs.
The fact that it's black and all in the background.
Pretty good contrast for being in the city. Here's another example of the double cluster. 36-minute exposure as well in that case. A little bit of a halo around the stars, which is probably from the sensor just getting saturated with those bright stars. Another great object, the Helix Nebula. This one taken from a little bit darker skies. That's about an hour of exposure time on that guy. And then galaxies. So there's the Triangulum galaxy. That was a little over a 2-hour exposure, but a very nice image there. And last, a little shot of the moon on the night these images were taken. So we had a fair bit of light pollution from the moon itself, and the Vespera still did a pretty darn good job. So we get to the slight sales pitch part of the presentation now. How much these things are. So the Vespera Smart Telescopes are $24.99, $2,499. And we also have the little portable backpacks. These are designed specifically for the Vesperas. I have a nice pouch to protect the telescope, little sleeve for it. and then place to put the tripod, charger cables, all that stuff, and then as well as a pocket for a tablet. So very nice, nicely padded backpack. And at this point, we'll open it up to Q&A.
How does it get the colors?
So it is a color sensor camera. How it gets the colors is it's a color sensor camera that's in the unit. So unlike our eyeballs, it's collecting all those photons over time and really bringing out those colors. So it's also doing, in addition to just capturing the image, doing a real-time processing on that image to stretch out those colors and make them clearly visible.
So that's the actual colors.
Those are the true color, yep.
Which we could not see with eyes.
We can't see it with our eyeball just looking through an eyepiece in a telescope. Yeah, so this is a unique aspect of astrophotography, is getting to see the color in these objects. John, we had a question.
We have a question from the live stream from Sang Chang, and the question is, what is the Bortle scale of the sky when you tested it?
So the question is, what is the Bortle scale of the sky when we tested it? We've actually tested it under a lot of different conditions. So I think Bortle 5 or 6 in some cases, and down to, what's the dark sky site?
Probably about 3.
3? Yeah. I think we've been as high as 7 in some cases too.
I would say the worst was probably my test on a full moon from the suburbs of Denver, and it still got M51.
Yeah, so we've done, you know, imaging under a full moon from the Denver suburbs, and we've still gotten pretty faint nebulae with it. So we're very impressed. Yep, next question.
Next question is from Deb Dicer, and she asks, is it color enhanced?
So the question is it color enhanced? The answer is yes. So it's true color, but it is stretched. And this is true of any astrophoto. So all of the astrophotos you see, that is the color of the object. Well, there's nuance to that. But when you're taking a picture with a color camera, a color sensor, and you're taking an astrophoto with that, the raw image you get off of that camera is going to look almost black before you actually stretch it out and pull out the detail. And that's what the Vespera and the software is doing for you.
Next question is from Bill Cast. How does the sensor compare to the Stellina?
So how does it compare to the Stellina? How does the sensor compare to the Stellina? That's a good question. And let me pull the Stellina out here real quick. Because I think the comparison of size is worthwhile along with this explanation. So the Stellina is, as you can see, a much bigger instrument. It's an 80mm aperture versus a 50, and it's a 6 megapixel sensor versus a 2 megapixel sensor. So if you're a serious imager, if you want to do print quality astrophotography, I'd say the Stellina is the choice for you. If you want to do casual observing, group viewing, social media sharing, the Vespera is more than enough. And we actually do have prints in the shop here from both of these telescopes, so you can compare and contrast. We've got the images we've taken with the Vespera uploaded to the product page on our website. I don't think we did that with the Stellina, but I will do that afterwards, so you can do your own comparisons. Next question.
Next question is from Roz. What is the frame rate during live view? I'm sure it does not allow live view during exposure.
Yeah, so what is the frame rate during the live view? And I'll take that to mean like the moon and the planets, the things where it's not doing stacking. It's basically taking an exposure there every, I think, 4 seconds or so, refreshing that image, because it's basically sending a new image over Wi-Fi to your device. The frame rate for the stacked images for the deep sky stuff, like the Dumbbell Nebula, that's going to be a frame every 10 seconds. And that's it for now? Okay. Zach, how are we looking cloud-wise?
Lousy.
Lousy, okay.
That's my technical report.
The technical report, okay. One more question here?
I was just wondering, if you use this just for at home, okay?
Mm-hmm.
Do you just plug it and come back 30 minutes later? Is that what you guys do? How do you use this versus a telescope?
Yeah. Yeah, so the question is, how do you use this versus a regular telescope? Do you plug it in and come back 30 minutes later and see the finished image? I'll say the answer is really up to you. I've used it both ways. I've used it where I've kind of just watched the image develop over, 15, 20 minutes, half hour. I've actually cast it up on my Apple TV device and put it on the big screen to be able to watch in the living room, which is a really cool thing to be able to do. I've also taken it out camping on a road trip recently, and I've just let it run while I slept in the car. Checked in, woke up around 2 a.m. Oh, that's a nice image, go to another target now, and gone back to sleep. So it works both ways, which is the really cool thing about it.
Related question, on your website or someplace, is there a listing of different nebulae and other images as to how much time is required to get each of those?
Yeah, so the question is about how much time you need for each object, the different objects, and that's actually something that the app itself shows. So we'll do a demo of that in just a moment. Do you have another question?
Yeah, you had mentioned that when we're looking at the images you had, we had some saturation of some of the objects. Can we reduce the exposure time to reduce the occurrence of saturated images?
Yeah, so the question is, can we reduce the exposure time to reduce some of the oversaturation on bright stars and things like that? Not right now. However, the Singularity software does have that capability for the Stellina today. There's advanced settings there where you can adjust the exposure time if you like. Right now that's not enabled for Vespera. I'm not sure if that's something they may do in the future.
Okay.
Another question online.
Deb Dysert asks, how did it work when camping in the mountains away from Wi-Fi?
Yeah, so the question is, how did it work off in the mountains away from Wi-Fi? And the answer is fantastic, because these devices create their own Wi-Fi network. There's no need for any kind of connectivity, Wi-Fi, cellular, anything else. This device creates its own Wi-Fi network for you to connect your device to. There's no internet connection, there's just the device connection. One more question coming in.
A question from Bill Jensen, who asks, if I ordered a Vespera from Mile High, is there a waiting period for receiving an order, since Vaonis indicates they don't have any stock available?
Yeah, so the question is about the order backlog, and if you order today, how long before you receive it? We actually have these in stock. There's a stack right here, and the backpacks are right here behind me. We put an order in with Vaonis very early on, so we had inventory available. And it's our policy that we don't do pre-sales when we don't have product on hand. So if you're buying through our website and it lets you complete a checkout, we have an actual telescope for you. All right, that's it for now. Since it's cloudy, naturally, when we try to do a live demo, what we're going to do instead is just take a little time to go through the app and some of its capabilities in a bit more detail. We won't bother connecting to a device outside. I'll just connect to this one here. So we'll power that guy up. take the big boy out of frame here. And you'll see the power buttons just on the side of the unit here. It's a little capacitive touch button. Very nice and pretty, also very sensitive. So I do usually turn it back on when I try to put it away. All right, so let's see. Which Vespera is which? We have two in the shop here that are turned on. So let's find out.
7 is going to be this Vespera here.
Is going to be this one?
Yep.
Okay. All right.
Androids is supported?
Yes, the app is available for both iOS and Android. We're using an iPad for demo purposes here, and you can see we're connected to our device. One important thing about the app is when you download it, and it's a free download by the way, and they do update it every couple of months. They add in new features, new objects, which is really cool. You have your observing locations, your space center as they call it, and you do want to make sure this is accurate to your location. In fact, what I'm going to do here is connect back to our regular Wi-Fi for just a moment, which makes it a little easier to set up a new location. So I'm going to add a new observatory. And let's see, I don't have GPS on this device, so I'll enter by address here. And it finds our store address there. I'll just name this MHA store. For those on the live stream, we are trying to shadow with two different iPads here, one for the TV and one for the stream.
What is our zip code here?
80215. So there may be a little bit of a lag. Yes?
We have a hole right around Milky Way. I won't promise, but it's there. M11, M22 are possible.
Okay.
Scope's outside.
All right. Let's give this a shot.
Won't promise, but it may be.
All right. So we're going to try to go for a sucker hole here. Let's see.
So you want Vespera 3 something.
There we are. All right, and you have control, that's fine.
Okay.
I will follow along. So we'll just show the...
Control if you would like.
Sure. Go ahead and release the control. So this is showing the two devices connected here.
All right, you should be good.
I can now take control. So you can switch off which device is actually operating the telescope versus just observing with the telescope.
So one of these is outside?
So we just set up one outside right in front of the shop, and we're starting that initialization process here. We'll see if the clouds get in the way or not. No promises.
Is it like go like
So basically the arm is going to open up and it's going to look at the sky and see what it sees. So you can go ahead and step outside there if you want to follow along with what's happening. And I, of course, can't really see what's going on outside. Tells you the Wi-Fi range works pretty good because we're about 50 feet away from where the telescope is set up. And we can go in here. Let's see, we were going to go for, I think, M22, which is a nice cluster. Just add that to the favorites. And we'll see if we get lucky with the clouds or not. Reminds me of my software days trying to do live demos.
I just had a bunch of new hires do that today.
That's why we did the CAN demo first, folks.
That's what I told them. So if I downloaded the software.
So I'm being told it's kind of iffy right now with the clouds.
That's what he said.
Yep.
It's okay. You never know.
All right.
You may get lucky.
Well, we'll stop that process for right now and maybe go back to it in a little bit. What we can do in the meantime, though, is go to the Catalog tab, and you'll see there's all of the objects here. If we click into one of those objects, it will show us the recommended observing time. So for something like a star cluster, that tends to be fairly short. Nebulas may be a bit longer, 30 minutes or so for that dumbbell that we showed earlier. And for a galaxy, 30 minutes, some of them will be 60 minutes. Depends how bright the object is. I also tend to like pushing this thing just a little bit, observing objects for 2 hours, maybe a little longer in some cases. There is a point of diminishing returns for a lot of objects. The dumbbell, beyond about 30 minutes, you don't really get much more out of it. It just keeps getting brighter in the core, but you don't see a lot more detail with it. So it's not something where you have to just keep imaging it relentlessly to get something impressive. Let's see. Oh, it's worth going over to the Library tab. And all the way at the top there are those 3 little dots. So we'll click on those. And that brings up the settings. And under here, there is a night mode, Astro Night mode, that will give you a red display. Red, of course, so you're not spoiling your night vision quite as badly by looking at a phone or a tablet. And below that, there's the parameters settings. And here you can actually tell it if you want to enable that TIFF export. Full resolution or not really only applies to Stellina. Vespera is always imaging at full resolution. The expert mode again right now is a Stellina specific thing. Fingers crossed they extend that to Vespera. And it's really that last option that we're concerned with here, that display object's position. I like having this turned on because if we turn it off and go back to the catalog, you'll see in the green text here on the recommended list, it'll just say a visibility, if it's good or not. And all the recommended ones, of course, will be good. But if we go back to the library again, to that settings, and back to parameters, and turn display objects position on, then when we go back, it actually shows the altitude and the general position, orientation of the object. So M27, altitude 59 degrees to the southeast. This makes it pretty easy to see, okay, I have clear sky in this area, and I have an object in that area. So that's what I want to image right now. Very handy feature. I wish they'd turn it on by default, but one of the things I always enable here. One last thing in the main menu that's of interest. There was the question earlier about, do you have to watch it build the images? You can actually set up an observing plan for the night. So you can basically tell it, I want to image these 3 objects overnight, and you can go to bed and wake up in the morning with some very nice pictures. So in terms of not wanting to lose sleep over your astrophotography, this is a big deal. So if we go to create a plan, and we'll say this is from the store here, click validate. You can select the date and time. We'll just say we're going to do this tomorrow night. Click validate. You can name your plan. My plan is fine for now. Validate again. And it will basically give you a nice little graphical interface to build an observing list. So we can start out with the Dumbbell Nebula. That second object there. Just click on that guy. And it will basically show the full range of time over the evening when that's visible. And we can shorten up the observing window. We only need about half hour or so on that guy. And click add. Then we can scroll down to that double cluster in Perseus. Click on that guy. And we can maybe add that in for an hour or so if we want to. That's really only about a half hour, 20-minute kind of object. Click add. And you can see, just scrolling through the list here, it'll recommend a bunch of objects that you can add in. You'll notice some of these have breaks in the middle of the blue lines. The North America, the Crescent Nebula, the Veil. And that's because that's when those objects are up near the zenith. And one of the characteristics of any alt-azimuth instrument is they don't track accurately near the very zenith. So it will basically recommend you go on either side there, about 10 degrees off of zenith, for imaging those objects. And in my own experience, that's accurate. It doesn't track well at zenith, and I wouldn't expect it to. So as you can see there, there's a lot of capability built right into the app in terms of being able to create your own observing plan. We can save that, close out of it, and that's scheduled for tomorrow. All right, I think our sky conditions are still not cooperating here, so I think what we'll probably do is take any last questions and then wrap up for the evening. But that is the basic introduction to the brand new Vespera. We're really excited about these. I know one of us has already bought one for herself.
Patience is hard. You can get it faster buying it here.
Yes, we do have them in stock, so, you know, if you just can't wait, they're here and waiting, and can be shipped out tomorrow. And we will, of course, be open tomorrow, too, so you can come on down to the store and pick one up. Any other questions on the stream? We're good? All right, so with that, I think we will wrap it up for the evening. Thank you so much for joining online. Thank you for coming into the shop here. And clear skies, unlike we have now.